I want to find out more about how the AI works in the original Age of Empires game. Partly for my own curiosity, but also partly because it upsets me that I get outsmarted by a 26-year-old program. My main goal is to try and figure out how the AI decides what to build next, and from there we can expand out our research as necessary. So looking at the strings, we can see this one called added build list item, which sounds like something the AI might do. That's called from this function, which copies that string into a stack buffer. Interestingly, it either copies the added builder list item or the set gatherer percentage string, which all sounds like AI tasks. At the bottom of that function, it copies that string along with a bunch of other data into a struct, and I think it then inserts that into some sort of linked list. So maybe this function is producing some sort of command struct. Anyway, I like to search for all the low-hanging fruit first before diving headfirst into any particular rabbit hole, so let's keep exploring. There's another interesting string called common AI history file started, which is only referenced from this function. Looks like it's passed a boolean argument, and if it's true, then it opens up a file called aoeai.txt directly in the C drive. This file pointer is then stored in some global address and used in a logging function. Now, since Vista, unprivileged processes cannot write directly to C or certain other protected directories. Instead, they're silently redirected to a virtual store in the user's app data location. But when I run the game, I don't get this file at either of these locations. However, if we look at where this function is called from, we can see the boolean is true if this global data is non-zero. Now, it is 0 at startup, and I have no idea if any code ever changes this, but let's just patch it to be 1. Okay, so now we can see the AOE AI EIEIO file with some debug information. It tells me some information about how the AI for this game was set up, as well as all these SN values it sets, whatever they are. However, nothing jumps out to me as unusual. Also, it looks like this logging only happens when the game loads. I've gotten distracted and played a few games, but nothing else is ever added to this file after the initial AI setup. Back to the strings, and I found error %d as an unrecognized action ID, which sounds promising, again, only loaded from one place and passed to our logging function. And that's called as the default case from some switch statement, but that function is only referenced from an array of function pointers. Looking at what references the start of that array, it looks like it's set as the first argument to some struct, so I suspect that this is a C++ vtable. But doing some research, it looks like the game was written in 13,000 lines of assembly, so I guess the developers decided to mimic some C++ concepts. Another roll of the dice on the strings, and we've also got entering task ID equals %d, which is only loaded from one function, but this function has loads of interesting strings in it. Checking on unit, going to send my units to attack, getting ready to task unit. These strings are all passed to a function which accepts a variable number of arguments, and the argument count seems to match the format in the string. Again, I suspect this is some sort of logging function, but the function itself is empty, so maybe it gets stripped out in a release build? So I'm going back through the vtable entries on the hunt for something interesting, and I found this. It looks like it logs players' stats, food, gold, stone, combat, etc. And it also has two conditional branches that print something specific for computer or AI players. This if statement is interesting. In both cases, it uses this offset to check if it should do AI things. So maybe we've been passed a struct for player data, and this flag indicates whether that player is computer controlled. Further down, the player information is grabbed from several functions, or just raw offsets and cast from float to int. These functions all loop through a linked list, but use the argument as some sort of if check against different node fields. So I've renamed a bunch of these based on how the result is logged. There's also a bunch of other functions which have this +ox238 offset check, but digging into this a bit more, some places in the code use this as an object, so maybe the offset is null if it's a human player, but some computer specific data for an AI player. Digging around a bit, each civilization has a setup function which sets a bunch of different values into an array, so these must be AI specific gameplay values. All these setup functions are referenced from here, which is a weird function. I think it might be too large for Ghidra to handle, and this purple hue suggests Ghidra is struggling to figure out if this is an actual function with a sane prologue and epilogue. In the actual assembly, there's a clear switch statement for setting up each civilization. However, the disassembler only shows one, and clicking on any other causes the whole function to be reloaded with only that as the new case. Not sure what it means, but there's also a bunch of rubbish halfway through the function, which is definitely messing up the decompilation. At the end of the misery function, it logs I am the X civ, so this is all set up chuff. Not sure what SN is, which we also saw in the log file, but it sets loads at the end and some are random. It's a bit of a stab in the dark, but if we look at the function for setting SN, just below this is another function which does the same bounds checks and returns the value, so this is probably a getter for SN, again, whatever that is. And it looks like our misery function is the only call site for this getter, but maybe it's accessed elsewhere in the code indirectly. Anyway, our log player stats function is never called, and by that I mean setting a breakpoint on the function and playing the game never causes it to be hit. Looking at our vtable function pointer array thing, it's oxec bytes offset from the start, and if we dump all the disassembly into a file, we can see that there's 50 odd references to this offset, but none look right, as in they don't have the right number of arguments. Let's go back to our getters. What I've called getPlayerTotal is probably called elsewhere in the code, and if we put a breakpoint on it, we can see it is hit every frame. I'm not too fussed about this function returning a valid value, so let's see if we can patch it to call our log function. The reason I think this can work is that the developers are using an ABI called thisCall, which means that the implicit this pointer for a C++ class is passed in ECX, and then all the rest of the arguments are passed on the stack. Despite being hand-rolled assembly, it looks like they've chosen to emulate this. Also, because this total getter is called from the logger, this suggests that ECX needs to be the same for both, i.e. you can call one from the other, and as we know the getter is called, we can then safely call the logger. The logger takes two arguments, a file pointer to write to and a boolean. Now, I'm not really prepared to try and open a new file and handle all this in assembly, but we know that the aoeai.txt file has a file pointer and it's stored in global memory, so we can just push that to the stack for the function call. Annoyingly, the small amount of space that we have between this function and the next isn't enough to call the logger, but we can just jump to this other free section and continue. Effectively, we're going to spread our code out across several code caves. We also need to patch out the call to the getter from the log function, otherwise we'd end up in an infinite loop. Once we've done the patching, we can export the binary from Ghidra and just copy it into the game folder. And it crashes. Let's change the boolean to false in case it's expecting some additional state or setup that's not been set. Nope. Okay, let's rewrite the assembly to be like a proper function with stack cleanup. Nope. Right, so let's just try writing some assembly that just pushes the args to the stack, doesn't make a call, and then cleans up. Nope. I'm clearly not setting up this function call correctly. In fact, it crashes on ret. Like, how hard is it to get ret wrong? Turns out Ghidra has snuck some extra bytes onto the end of my ret, which was causing some weird behaviour. Okay, so the game now runs fine with the extra code that just sets up a function call but never calls it. We can see the problem if we actually look at the assembly. The log function is not passing along ECX to these getters, but rather ECX plus ox34. This is the issue with the disassembler, which glosses over this fact. We're basically capturing the wrong object. Really, the log function is passing a sub-object to the getter, so when we patch the getter, we're really passing that sub-object back to the logger instead of the parent object. Looking up the call stack, we can see that the value we want is calculated as EAX plus EBX. So let's hope that this is the only call site and reconstruct the original pointer from these registers. It still crashes, but it's actually passed through all the code and it's crashing on the ret again. I can see the stack is in a weird state. It's not at the same point at the end of the function as it was at the start. I've seen my problem. I've cleaned up the stack args, whereas the callee also cleans it up, so I can just simplify my code a bit. And it works. Annoyingly, it only gets called for us, which isn't that useful as I know I don't have any gold. Let's go all the way back to one of the first functions we looked at, which seemed like it's handling some sort of AI command. As we never ran this under a debugger, let's try this now. Okay, so it's hit and it looks like it's passing in building names. However, it's not getting called with all building names, which is expected and I'll come back to in a second. Anyway, I can see it's building a house, and a storage pit, and a granary. The call site for this is a massive switch statement, so I'm thinking that this might be the driver behind the game's AI. We've covered a lot of ground, and there's still some ways to go, but to see how we know how the AI already handles certain buildings, then check out this next video.